So we're going to continue section 3.1, which is about tangent lines. And we're going to look at the following problem. Let's find the slopes of the tangent lines to the graph of the function x squared plus 1 at the points 0, 1 and -1, 2. So the first thing I'm going to do is look at my points. I had 2 points and they were 0, 1 and -1, 2. So remember, when we're looking at a tangent line, we have a c value, the tangent line at x equals c. So let's identify our c values here. If I'm looking at the point 0, 1, our c value would be 0, so that's our x value. And then our other point, -1, 2, our c value would be -1. So here I have 2 different c values. So let's compute the slope of the tangent line m for an arbitrary c. So the limit as delta x goes to 0, f of c plus delta x minus f of c over delta x. So now what I'm going to do is I'm going to take c plus delta x and plug it in place of x in my function. So this will become the limit as delta x goes to 0, c plus delta x squared plus 1 minus c squared plus 1 all over delta x. And now I'm going to need to FOIL that out. So if you FOIL that out, what are you going to get? You're going to get c squared plus 2c delta x plus delta x squared plus 1. Let's go ahead and distribute this minus c squared minus 1. And you should see some things that cancel. C squared and minus c squared, 1 and -1. And then I'm going to take what's left in the numerator. All my terms have delta x in them. So factor out a delta x. And now I can cancel delta x in the top and the bottom. So I'm left with the limit as delta x goes to 0 of 2c plus delta x. Now, because I no longer have a fraction, I can plug in delta x as 0 and just get 2c. And that's our slope of our graph, of the tangent lines of the graph. And so now I can plug in my c values. So when I had the point 0, 1, we said our c was 0. So what would our slope be? M would be 2 times 0. It's 0. And then the point -1. The point -1, 2. Our c value was -1. And our slope, if we plug in 2 times -1, -2. So there are my slopes of my tangent lines. Now I will mention you could graph this function just to verify that those answers make sense. So if I graph y equals x squared plus 1, it's a parabola. Shift it up 1. So here's my parabola. If you look at the point 0, 1, the slope of the tangent line would be horizontal there. And so the slope would be 0. If I look at the point -1, 2, my tangent line points downward, so it would have a negative slope. All right, and then I want to mention when you get a vertical tangent line occurs whenever you take the limit of delta x goes to 0 of your difference quotient here, and you get either infinity or negative infinity. So if you take that limit and get infinity or negative infinity, that means you have a vertical tangent line.